Body executes simple harmonic motion of period 10 seconds. 1 second after it has crossed the mean position, the body has a speed 5 cm per second. Calculate amplitude of the body. The theory we are going to use is speed of a particle in simple harmonic motion. V is equal to omega root of a square minus y square, where v is velocity, omega angular velocity, a amplitude, and y displacement. The equation for displacement of a particle in simple harmonic motion, y equal to a sine omega t. So instead of y, we can substitute a sine omega t here. A is taken outside the square root. We get a omega here, and inside 1 minus sine square omega t, that is v is equal to a omega cos omega t. Given v is equal to 5 centimeter per second, time period 10 second, and time t is equal to 1 second. Omega equal to 2 pi by t. Here t is 10 seconds. So we can substitute 10 instead of t. On calculating, we get omega is equal to 0.628 radians per second. Next, we have to find omega t. For substituting here, omega t is angle theta. Omega is 2 pi by t. We have 360 degrees equal to 2 pi radian. Here we have to substitute for angle. That is, the answer should be in degree. So instead of pi, we can write 360 by 2, that is 180. So 2 into 180 by 10 into 1 equal to 36 degree. V is equal to a omega cos omega t. A is equal to v by omega cos omega t. V is equal to 5 omega pi by 5. Pi is here and 5 goes to the numerator. Cos omega t. So for omega t, substitute 36 degree. On calculating, we get amplitude A is equal to 9.84 centimeter. A body in simple harmonic motion on a straight line has velocities 4 meter per second and 3 meter per second when its displacements are 1 meter and 2 meter from the mean position. Find out the period and amplitude of its motion. The equation for velocity v is equal to omega into root of a square minus y square. In case 1, v is equal to 4 meter per second. So v is equal to 4 meter per second here. And displacement for the case 1 is 1 meter. That is y is equal to 1 meter. We can substitute these values in this equation. Instead of v, 4 is given, and for y, 1 is given. 1 square is equal to 1. So 4 is equal to omega into root of a square minus 1. So this is the equation number 1. For case 2, velocity is 3 meter per second and corresponding displacement is 2 meter. We can substitute these values again in the equation for velocity. V is equal to 3 and y is equal to 2. On taking square, q square is equal to 4. So 3 is equal to omega into root of a square minus 4. This is the second equation. On dividing 1 by 2, we get 4 equal to omega into root of a square minus 1 in the numerator and 3 equal to omega into root of a square minus 4 in the denominator. On squaring, 4 becomes 16 and 3 square 9. Omega get cancelled from the numerator and denominator, and the square root also goes on squaring, and we have a square minus 1 in the numerator and a square minus 4 in the denominator. On cross multiplying, 16a square minus 64 equal to 9a square minus 9. On taking 9a square to the left hand side and 64 to the right hand side, 16a square minus 9a square equal to 64 minus 9. 16a square minus 9a square is 7a square and 64 minus 9 is 55. So we get a is equal to root of 55 by 7, which is 2.8 meter. So the amplitude is 2.8 meter. We can substitute these values in the equation number 1. 4 equal to omega into root of a square minus 1. Instead of a, we put 2.8, and on calculating we get 4 equal to omega into 2.615. Omega equal to 4 by 2.615 equal to 1.52. Omega is 2 pi by t. This is equal to 1.52. T equal to 2 pi by 1.52, which is 4.13 second. So the period t is equal to 4.13 second.